Hello, everybody. Hi, Greg. Hi, Miro.
Cheers.
Hey guys.
How are you? We are going to wait for a couple of minutes for everybody to join us. We are very excited to be here today to talk to Miro and Greg about composability feature, which I know is a beloved feature of NeonVM by so many participants of the bootcamp that we've recently been running on NeonVM. And we saw that a lot of participants posted memes about composability. They made some sort of blog posts and highlights how they understand composability feature. And of course, we want to continue talking about it. We want to clarify a couple of things about composability. And I'm hoping that, it's going to be fun today to talk about this beloved feature by everybody with the developer and analytic business analyst who created it for NeonVM and kind of conceptualized it in a white paper, and also created a lot of code base for our developers, for users to interact with Solana from the Solidity contracts through composability libraries and a lot of other stuff. So we are waiting for one more minute before we start. How are you guys? How are you today? Let's start with a simple question.
Well, we are starting with hard ones already, but we are fine, I guess. Happy to be here.
What's the weather like today where you're based?
In Poland, it's actually sunny. So it seems that these are the first sunny days that we get this summer. So it feels good.
Yeah, I've heard it's been raining for like almost whole summer around Poland and Germany.
True, true. So I'm trying to catch as much sun as possible.
Yeah. I hope you can catch some sun from here. Yeah, sorry for keeping you from the sun with this space. But okay, it's 3:03 already, and I think we are ready to start. Hi once again. Let me start with a round of introductions. My name is Julia. I'm DevRel at NeonVM, and recently we've run a Neon Dev Bootcamp where we learned a lot about composability feature, and we saw a lot of interest in this feature by the developer participants, from the developer participants. So we've decided to talk to the people from NeonVM who's been the most involved maybe in the creation of composability feature, and ask all the hard and hopefully easy questions as well to learn even more. So Greg and Miro, could you briefly introduce yourselves and tell us what do you do at NeonVM and how are you connected to composability feature?
All right, so I am the lead business analyst, so I'm responsible for connecting product and developers teams, understanding what our products are actually doing and defining their architecture and putting everything on paper. And in terms of composability, I was responsible for creating the white paper. And I have to admit that indeed the first time I've met the concept of composability, it did sounded like a magic to me. So maybe so don't worry if it sounds magical to you as well. I will try to unpack it a little bit today, but it's not the easy concept. So even to myself working here, it took me some time to actually fully understand or understand to the degree to a certain degree how the composability works and to be able to put it into the paper.
Thank you. Miro, could you briefly introduce yourself as well, please?
Yeah, hi guys. Thanks for having me today. So basically, I'm the Solidity team lead. I was leading. I'm still leading a team of Solidity developers. So basically, my daily tasks is to understand the concept of Solana and Solidity, migrate them together, and basically to put aside all of the limitations and try to basically integrate stuff. And yeah, composability is actually one of the main things that I was dealing with for the last few months. So by the time that we pushed this feature live, I was part of another team. Uh, so can you guys hear me, or I'm losing some
Yeah,
connection?
yeah, we can hear you.
Sorry. So yeah, by the time that we pushed the composability feature live, I was part of our integration team. So my first task was to basically check the feature, spot some issues, see how we can make it even better and stuff like that. But recently I got moved into the Solidity team, and where I lead it, and basically my responsibility was to ship the composability libraries that we're going to speak of today, and yeah, trying to basically abstract away all of the Solana specifics and make the things easier for EVM developers. And yeah, that's pretty much in a nutshell.
Thank you so much, Greg and Miro. So let's start with the first question with an elephant in the room. What is composability? How would you describe it to non developers and to developers? Greg, what do you think?
So I think on the highest level, the definition would be that from in the context of Neon EVM, composability is kind of the technical framework that enables Ethereum compatible smart contracts that are written in Solidity to directly and automatically interact with native Solana programs. So what it essentially does, it allows contracts written in Solidity to construct and send Solana formatted transactions. And I think it's important to highlight one aspect because in the white paper, but also in other occasions, we are using cross-chain or bridging terms. But it is not a bridge per se. It is native solution in a sense that those transactions that are being created and constructed and sent to Solana are native Solana transactions. So they work like any other Solana transaction. So it's not bridging, even though we are using this term, but for lack of better wording, that has been mentioned a couple of times in the white paper.
Yes, we are trying to use the word connect, I think, instead of bridge, because, yeah, it's very different from that. And Miro, how would you define composability?
I also would like to stay a bit far from the word bridging, because bridging usually is not atomic. I mean, it requires two separate transactions, but on our side, the composability feature is atomic. I mean, from the new NVM Solidity environment, you can request Solana atomically, and that's the unique feature about it. Because I mean, if I have to explain it to a non-technical person, I would say that in our new NVM chain we have a door to Solana, and it's your I mean it's your option if you want to use that door or no. But basically, the cool thing is that you basically can process whatever logic you wish. I mean, for example, even from the beginning of new EVM, we had the composability, but it was at the beginning it was a bit limited. For example, ERC24 SPL. I mean, you could eventually request Solana, but in a limited way, where you had only a few options of methods and programs to be uh, requested. But now, through uh, a custom precompile deployed by Neon, you could eventually request any type of program on Solana. If tomorrow, for example, some new program gets deployed on Solana, your hands are wide open to request that. So that specific program. So basically, it's entirely up to the protocol's business logic and desires. You could build anything on Neon and access Solana's liquidity. So yeah, in a nutshell, I would describe it as a door to Solana.
Yeah, and I think one important aspect that Mira mentioned is what we were focusing on as well, is the abstraction. Because essentially many things that we will be discussing, like accounts, additional libraries, and other tech details, were created to abstract as much of the differences in the architecture between Ethereum and Solana as much as possible, so developers can focus actually on building instead of trying to understand those nuances. So abstraction was also key of the development ideas that we had in mind.
Thank you so much. And that moves us to the next question, which is about how did this idea come to life? What other solutions did you consider and had to discard? And why did you decide to choose composability in this design that we have now?
Yeah, maybe I can handle that one. So, for example, like I did mention, 2 years ago, we shipped the standard called ERC-24 SPL. Basically, on Ethereum, you have the standard ERC-20, and on the Solana side, things are a bit more centralized, where you have to deploy your token at a specific program, which is the SPL token program, and we basically created a EVM wrapper of that program. But of course, that integration, that ERC-24 SPO, it came with predefined methods. For example, we did support the core methods of ERC-20, for example, such as transferring, delegations, depositing to smart contracts and stuff like that. But with the time passing, for example, new features arrived on Solana, for example, such as token 2022, and we cannot be sure what else will come in the future in Solana. So I guess here comes composability, where, for example, you could grab the standard that we shipped in the past, and eventually build it based on your purposes through the composability. For example, let's say if now you want to have fees inside your token on each transfer. Let's say your business logic requires a small percentage of fees to be taken out of the protocol for each transfer. Now you're able to do this with composability, and we don't have to, let's say, catch up with the updates coming out of from Solana. So everything is just up to date, and you have to build your own instructions. And yeah, that's pretty much.
Thank you so much, Miro. You started talking about ERC-24 SPL token standard and explained to us that, well, basically the standard kind of maps Ethereum's ERC-20 interface to Solana's SPL tokens. And I was wondering if you could explain why was it important to create this kind of ERC-20-like experience for Solana tokens, and how does ERC-24 SPL work in practice? If we take, for example, a transfer function as an instance, as an example of it.
Yeah, sure. So going back to the Ethereum's approach, so things on the Ethereum looks a bit more decentralized, where, for example, you have the ERC-20 standard, and then every developer is free to grab it, modify it as they wish, and just deploy the code. But going back to Solana, I mean, things are a bit more centralized. I mean, you have that program, you deploy the tokens there. And the thing is, we had to basically wrap together the both standards. And the good thing is that in the core of them, they hold the similar methods. So we just had to map the methods. And for example, if you take a plain ERC-20 contract from Ethereum, you will notice that states such as balances, delegations, and stuff like that are being recorded into the state of the smart contract. But in our approach, the ERC-24 SPO, the actual data is being stored on Solana. So basically, our standard is modified in a way that, for example, the transfer method that you mentioned is not actually changing balances and recording data in the state of the contract, but it's actually performing read and write requests to Solana. So the whole time the tokens are actually existing in the context of Solana, but we just created a EVM wrapper which is able, with your Ethereum's private key, which is 32 bytes, to basically perform state changes. So all of those permissions are being recorded into the new EVM program, and only you with your EVM private key, you're able to perform state changes in your SPO account. I guess one more thing that could be mentioned is that uh, how different are Ethereum and Solana. So, for example, on Ethereum, you have your address, and for example, if you go to Etherscan, you can see all of your balances there. But on Solana, things are a bit more split. For example, for each token, you have a dedicated token account. And so, how ERC24 SPO works is we generate a dedicated token account, which is owned by the new EVM program, but only you have the permissions with your Ethereum's private key to perform state changes in Solana. So, yeah, that's pretty much ERC24 SPO. And actually, what's the idea behind ERC24 SPO is actually to bring access of Solana's liquidity to Neon. So, for example, all of those tokens that you see on Neon, USDC, USDT, for example, Rapsol, they do not exist in the context of Neon, but we just read them from Solana. So, yeah, that's pretty much.
Thank you, Miro. And you've mentioned these fundamental architectural differences between Ethereum and Solana in token standards and in account models. I was wondering, what were the biggest architectural gaps you had to overcome to make them interoperable, to make Solana and Ethereum interoperable?
Yeah, I think if I may shortly, I think if we are talking about the challenges between architecture of Solana and Ethereum, there are three main aspects. The first one is token standards that Miro just described. One of the larger ones, I guess, would be transaction and execution and the execution context itself, because Ethereum processes transactions sequentially, which means one after another. And at the same time, Solana's architecture allows for the parallel execution for speed. And that means that it doesn't allow to access the same state, which on one hand leads to the much higher throughput. But on the other hand, if we wanted to maintain the parallelism and still be able to handle EVM transactions, we had to architect for that. And also, there is another aspect, which would be the size of transactions, because EVM transactions can be much bigger and they can exceed compute units of per transaction limit on Solana. So I guess those core differences were the most challenging.
Yeah, thank you, Greg. What do you think, Miro? Does it look the same from your point of view?
Yeah, going back to what Greg just said. So because Solana, because Ethereum is processing transactions sequentially, like one after one, and how Solana basically unlocks the parallel execution. First, state and logic are separated. This is something unique for EVM developers that they have to deal with. So this is something also another issue that we had to handle during the build-up of composability libraries. And so state and logic are separated. And the second thing, by the time of requesting some kind of logic to be processed through the composability feature, you have to list all of the accounts by the time of broadcasting the instruction. So this is how actually Solana knows which accounts are going to be touched, let's say, and they filter out what is not going to be like. They filter out transactions that are not going to collide, and they're processing them in a parallel execution. So this is something also to consider when it comes to the composability feature.
And speaking about Solana's transaction design, how does composability deal with Solana's atomic transaction design? So if a transaction fails on Solana, it gets reverted due to Solana's atomic transaction design. But how does composability deal with this, taking into the account that we are writing Solidity contracts?
I would say that is a very key moment in the context of EVM developer because, for example, uh, when you process composability requests, of course there are two options: to success the call or to have it reverted. And the thing is, on Solidity, you could eventually handle all of the reverts to external smart contracts. But when you request, for example, some Solana program through the composability feature, if that specific request fails, for example, you're trying to transfer an amount bigger than your balance, then the whole execution of the whole method stops. So this is where some stuff cannot be fully how to say it, optimized when it comes to batching EVM and SVM logic. But yeah, that's the nature of Solana, and we have to play by the rules. But I believe that it's not a huge issue. I mean, some stuff can be estimated off chain, and for example, if you see that your composability request is about to fail, you just do not process it at all. And yeah.
And it's good that we have error handling within composability libraries because they allow to deal with errors somehow from Solidity side. Miro, could you tell us a bit about those composability libraries? Um, can the community build their own libraries, for example, for other protocols that we haven't covered yet at Neon? And how do these libraries work?
Yeah, so basically, let's start from what's the idea behind the libraries. So when we had the composability feature ready, and when we showed it to external developers and partnerships, we saw that it's a bit hard for EVM developers to dive immediately into the Solana specifics and stuff like that. For example, when you build composability requests, you have to deal with Souls, which is the native token of Solana. Uh, for example, creation of account also requires fee to be paid. The creation of account is also a new concept. You need to know, like I did mention already, by the time of processing and building an instruction, you have to define all of the accounts that are going to be used into the overall execution. So all of those Solana specifics are very new for EVM devs, and we try to abstract away all of those new things for EVM devs, where we started to create a set of Solidity libraries, which basically to not get EVM devs a bit frustrated with dealing with some kind of new stuff. And basically, we tried to follow the top names building libraries and trying to see how the community would like to use such libraries and the requests. And basically, we started with the default programs being supported on Solana. For example, the system program, it's a program for creation of accounts, dealing with native transfers. The SPO token, without this program, I mean, it's not possible to deal with SPO tokens at all. For example, transfer and delegates and stuff like that. The Metaplex, which is the on-chain metadata. And then when we had this set of, let's say, default libraries, we wanted to build one library which is for a program which is not provided by the Solana Foundation, but also but from external team. So we decided that the Radium one makes the most sense. So we built the library for the Radium's constant product market maker program, which is let's say, in simple words, the equivalence of Uniswap v2 but on Solana. And yeah, for all those libraries, the main idea was we had multiple internal reviews of different developers, which are mostly with the Solidity background inside the company. And the core idea was to build the libraries in a way that you don't have to know much about Solana. Of course, at the end, you still have to have a very high level understanding of Solana, but you don't have to deal anymore with account creations, dealing with soul balances, accounts, and stuff like that. I mean, the libraries basically contain each library contains three different sections. For example, the actual builder of the instruction, the first one. The second one is building and generating getters. For example, you have many accounts and many methods on Solana, so we migrated those into Solidity methods, so Solidity developers can use them. And as you just mentioned, for example, when you request Solana, it comes with Solana encoded errors. So we try to provide those in a way that a Solidity developer and a contract can handle them and yeah, do some stuff when error is initiated. So yeah.
If an external developer, if a developer from our community wanted to create a library of their own, how would you suggest they go about it? Where to start?
Uh, yeah, I guess building a library would require a bit deeper Solana knowledge. I mean, but they can definitely follow what we already built and reuse it. Of course, the default libraries that I did mention, it's they do not have to reinvent the wheel. Let's say they have to they can, because each external program, for example, it doesn't matter if it's a lending protocol or DEX, you have to deal with account creations and tokens and stuff like that. So they can definitely reuse the default programs that we built for the native and the SPL token transfers, reuse them and build their own libraries by following what we did for Radium, for example. So it's a pretty permissionless process. They can definitely do that by themselves, or they can reach out to us for help, for example.
Okay, thank you so much. And I also wanted to touch upon this very difficult topic of Solana's account complexity. And you've already mentioned a couple of things about how Neon deals with Solana accounts, so with creating program-derived addresses and associated token accounts. And I was wondering if you could go a bit deeper into this topic and tell us a bit more about Neon's approach to Solana's account handling.
Yeah, sure. So basically, I guess that's a bit a hot question because looking from a dev perspective, you have a EVM chain which runs with 32 bytes private key, and then you have which that chain is running on top of Solana, which of course uses 64 bytes private key. So how exactly the, let's say, the integration was done? Well, basically, when you I don't want to say open account, but when you create an address, for example, in MetaMask, and you connect to our chain and you receive some tokens, what happens is that, uh, like I did mention a bit earlier, for each token you have, for each token balance, you have a dedicated token account on your side. So on each receiving of token, there is a dedicated account creation, which is linked to your Ethereum address. And basically, by receiving multiple tokens, there are multiple token account generations, and they're all derived from your uh, Ethereum public key. And this is how we know, for example, which EVM address can make state changes over the SPL token accounts. And yeah, what else? Yeah.
Thank you. And I also wanted to ask Greg because he wrote a paper about Neon EVM thinking of different solutions to Solana's account limitations recently. And that's why I wanted to address this question to Greg as well.
I think I wouldn't be able to go deeper than what Miro mentioned in terms of accounts and Solana's account complexity. There is topic of PDAs, which are program derived addresses, associated token accounts, and payer accounts, which were covered by Miro.
Yeah, but we are going to post a link to this incredible article that Greg posted some time ago about an approach, this container approach, which sounds very exciting and deals with Solana account limit. Last couple of questions I wanted to make a bit personal. Sorry about that. But I think that a lot of beginner developers, especially, are interested to know about your personal story, your personal background, and career background. Basically, how you came to work at NeoNVM and working on composability, because I think it's interesting to see what kind of dev experience can lead to becoming the masterminds behind such incredible and very difficult technology.
So I think it's pretty funny from my side because I started my professional career nearly a decade ago. And I still remember this story because back in the day, 10 years ago, the first interview I had was for what I was thinking and I was applying to was for the developer. And back in time, I know that it's not relevant for the crypto, but it was for Java developer. There was mix up and it was actually different position, but I followed that. So far, I went through data analytics and engineering, some management positions. And a few years back, I was very lucky to jump into the business analyst position in one of the crypto startups, which was more focused on AML topics and highly regulated fields. But that was how I was able to get the first foot into the blockchain world, which consumed me completely because professionally it's all about blockchain from my side, but personally it is as well. So yeah, it can be a bumpy road, but what I really like about this industry is that everyone is very much welcome. And even though it's kind of the niche and you have to have proper skills and know the technology, uh, the the blockchain world is very welcoming, and it's actually very encouraging to try joining. And I think that's also something, if I were asked what's my suggestion for anyone who wants to join the industry, I know there would be different answers, like try to build something by your own and those kind of suggestions. But I think the main strength is in the community. So if I were younger and I was about to say to myself what I should be doing differently, I would try to join the communities earlier. It doesn't matter if it's about boot camps, hackathons, or some local communities, or it's about Solana's super team, or anything else. People are always very helpful, and I think that's the quickest way to actually enter the industry and make the impact.
Awesome. Yeah. I love your background. It's so complicated.
That's a
Miro.
perfect word. It's complicated.
Yeah.
Absolutely love that.
Yeah. Miro, what about you?
Yeah, so my background, I started in the first place as a backend developer, but then I remember during a break into the office, I was scrolling just Twitter, and I saw that I do not remember the exact article, but I do remember something like 400 millions have been stowed
Yeah.
into a hack of Solidity smart contract, and I was like, oh, this is crazy. I mean, this is something that I need to get involved, not only not in a malicious way, but yeah, but basically I was just surprised that the amount of money being kept into those technologies. So this is how I got into crypto and blockchain 5 years ago. But in the last 3 years, I'm more focused on the DeFi side of blockchain, all about DeFi security and stuff like that. So even lately, as a hobby, I'm participating in few auditing contests where I try to study different DeFi protocols, spot issues and bugs. Uh, which helps me a lot to stay in track with the latest trends, protocols, and stuff like that, and also helps me a lot to understand the mindset of developers and builders, because it's very interesting when a developer is coding something, is shipping a smart contract. He's thinking defensively. He's trying to secure the assets. But when an auditor or an attacker is looking into code and trying to exploit it, he has an attacker mind, and he's trying to to find exploits. And when you look at from that perspective, you start to think like the same way as an attacker would think, and you try to basically make the smart contracts more secure. And basically another interesting thing is for my time in Neon, this is the first time I'm dealing with Solana. I'm completely amazed by the Solana community, and how alive is Solana. And we as a Neon, we are in the middle of EVM and SVM, and we take the best out of it. Yeah.
Yeah. I speak to some developers in interviews sometimes, and I ask them which community and which ecosystem they find more developer friendly, Ethereum or Solana. And I think most of them are saying Solana. I wouldn't say all of them. No, some of them are saying Ethereum because there are a lot of background forums and stuff like that. But when it comes to friendliness and helpfulness of the community, most of them say Solana. Yeah.
Yeah, definitely. I was at a Solana Hacker House, I think last year. It was crazy. I mean, people were just there sharing and discussing a new. I mean, it even feels like that Solana events are even more alive currently than Ethereum. But yeah, let's see what the future holds.
Yeah. Yeah. Thank you so much, guys, for participating in this space and explaining to us a lot about composability. Thank you all who joined us today, and we are going to send the links. Well, I'm going to send it from my personal account, but anyway, we're going to send the links to the work that these two incredible minds have done on composability, and follow them on Twitter. They have so many cool insights to share. Thank you so much once again. Have a great day. Bye.
Thanks. Bye
Thank
bye.
you. Bye.